good morning, my dear students. Welcome to this chemistry digital class. Today on 19th August 2020, we are going to discuss about the one of the very important topic of the chapter that we have already started. The chapter name is coordination compounds. The meaning of coordination compounds came from coordinate bond, as you know that, and compound came from transition metal. It means that we are going to discuss about the information of coordinate bond and transition metal. Yeah, you can say the coordinate bond in transition metals. So what is coordination compound? These are the complex compound which formed by the transition metal, in which the metal atom are bounded to the number of anion and neutral molecules through the coordinate bond. Okay, we will go discuss what is the most important. These are the complex compound first. These are complex compound, large compounds, okay, which is formed by transition metal, D block element. I'm going to write the information side by side so that it will clear to you. It is the large compounds between D block elements or metals, in which the metal atom are central metal atom are bounded to the number of anion and neutral molecule through coordinate bond. The information is there. Coordination compound are those complex compounds which is formed by the transition metal, in which the central transition metal atom are bounded to the number of anion and neutral molecules through the coordinate bond. Okay, so basically the chapter is divided into three parts: introduction part, isomerism, and theories. Introduction part, okay, that we have done. Today we are going to do isomerism, and then from tomorrow we will start the theories, different theories. So first, in introduction, dear students, in introduction we have already done under this introduction the important terms, and it is my appeal now you all should learn these terms, because without these terms you cannot do the future topics. So coordination compounds, already we have discussed the definition. These are the complex compounds formed by transition metal, in which the metal atom are bounded to the number of anion and neutral molecule through the coordinate compound. Coordination entity. Now coordination entity is what? It is the constitution of a central metal atom or ion attached to the fixed number of anion and neutral ion molecule. It may be positive, negative, and neutral. Okay, so all those compound which is written inside this bracket is called coordination entity. Central metal or ion, it is D block element. It can be from D block, like it can be I can say chromium, cobalt, nickel, copper, zinc. It can be anyone. Okay, ligands are positive, negative, or neutral. Those all molecules, those all elements are called ligand, which is going to attach with central metal, and these ligand are giving a lone pair to form a coordinate. Coordination number. Coordination number is the total number of ligand to which the metal is directly attached to the coordination sphere, which is called coordination number. Again, the total number of ligand to which the metal is directly attached, to which the central metal is directly attached in the coordination sphere, is called coordination number. Okay, next is coordination sphere or coordination counter ions, you can say. Coordination sphere is what? It is the central atom or ion and the ligand attached to it are enclosed in the square bracket. All things that is enclosed inside the square bracket are collectively known as coordination sphere. All those things which is enclosed inside the square bracket is called coordination sphere. Here coordination entity is everything, whole equation. Okay, and coordination polyhedron. Coordination polyhedron, it is the special arrangement of the ligand atom which is directly attached to the central metal, and the most common coordination polyhedron are octahedral, square. This is, you can say, simply shape or geometry of coordinating compound. Okay, after that, dear students, we have started nomenclature, in which basic rule of nomenclature, yesterday also I told in my live class, basic rule of nomenclature and name of the compounds. So as one test I took before this, so hope so you all will you all understood and you all are able to write the name now. Now, dear students, welcome in the today's topic, that is isomerism. This topic you have studied in 10th also, in which you know what is this. Same chemical formula, isomerism has same chemical formula with different structure. Okay, with different structure. It is same chemical formula with different structure. So here we will do, there are two type of isomerism, structural isomerism and stereoisomerism. So first we will do structural isomerism, under which four different isomerism is there: ionization isomerism, solvated or hydrated isomerism, coordination isomerism, and linkage isomerism. Whereas under stereoisomerism there is two type of isomerism: geometrical isomerism and optical isomerism. Okay, if I will take the word structure, so here somewhere geometry, structure, shape or formula, it is going to change. Whereas here stereo mean alignment, I can say alignment, or you can say mirror image, mean geometry is going to shift, okay, to directional, I can say directional, it is directional. Okay, stereo mean shape is going to change. So here let's start. What is the meaning of structural isomerism? So first, what is structural isomerism? First thing is, what is isomerism? Again, I'm taking isomerism. Two or more compound having the same molecular formula but different arrangement of atom are called isomers, and the phenomenon is called isomerism. Isomers can broadly classified into two major categories: structural isomerism and stereoisomerism, in which structural isomerism are the isomers which have same molecular formula or chemical formula but different structural arrangement of atom or group of atom around the central metal ion, and these are called structural isomerism. Okay, whereas there are different type of isomerism: ionization isomerism, solvated isomerism, hydrated isomerism, coordination isomerism, and linkage isomerism. So first let's discuss ionization isomerism. These are the compound which have same chemical formula but different, giving different ions in the solution, but giving different ions in the solution. Once again, these are the isomerism which have same chemical formula but giving different ions in solution. For example, if we will take this formula, 1 cobalt, 1 chromium, 5 amine is there with sulfate, whereas here cobalt, sulfate, 5 amine and 1 bromine is there. The difference is what? Here some sulfate ion is there outside the coordination sphere. Here bromine took place of sulfate and sulfate took place of bromine. So this is the isomerism, ionization isomerism, where ion is changed. So sulfate ion and bromine ion has changed. So hope so you got. Next is solvated or hydrated. Here hint is H2O. इसका मतलब है कहीं ना कहीं water कम या ज़्यादा होगा. Same chemical formula. These are the isomerism where same chemical formula but different position of Y hydrated or different number Y hydrated, or you can say some of the molecule which is having hydrated and non-hydrated molecule. Suppose here chromium 1, 3 chlorine, 3 molecule of water is there, whereas its isomerism 1 chromium, 1 chlorine here, 2 chlorine outside now, and 5 H2O is there, 1 H2O is outside. Okay, sorry, here it is 6 H2O. If 6 H2O is there, that means that 5 plus 1, 6 H2O is. Here you can see all 6 hydrogen water, hydrated water is inside the coordination sphere, where here 5 is inside the coordination sphere and 1 is outside the coordination sphere. So that way, in that way, same formula is there, but number of hydrated are different. Next is coordination isomerism. These are the chemical formulas, or these are the isomerism, the type of isomerism which occur in compound which is containing both cationic and anionic, which contain both cationic and anionic entities, and the isomers differ in the distribution of ligand in the coordination entity of cationic and anionic part. This type of isomerism arises from the interchange of ligand between cationic and anionic ligand. For example, 1 cobalt, 6 amine is there with cobalt. At this time 6 amine is with cobalt, and at this position 6 cyano is with chromium. But its isomerism is what now? Now cobalt took chromium place and chromium took cobalt place. It means that now 6 amine is with chromium, whereas 6 cyano is with cobalt. Okay, so this is the position of cation changed with anion. That kind of isomerism is called coordination isomerism. Next is linkage isomerism, where same molecular formula but differ in mode of attachment of ligand. मोड ऑफ अटैचमेंट मतलब जिस माध्यम से या मीडियम से ये अटैच हो रहे हैं लिगेंड. फॉर एग्जांपल हियर NO2 is having one N, 2 oxygen, where nitrito, in case of nitrito, N is attached. If N is attached through N side, it is attached with metal, then it is called nitro. And when oxygen, again 1 and 2 oxygen is there, oxygen is here, you can see oxygen is attached, then it is called nitrito. It is called nitro, not nitrito, it is nitro. This is called nitrito. Okay, this is the difference. After the structural isomerism, there are stereoisomerism. So stereoisomerism, as I said, alignment or direction. So stereoisomerism can be defined as those isomers which have the same position of atom or group, but they differ in special arrangement around the central atom. They differ the special arrangement. Those isomerism which have same position of atom or group, but they differ in the special arrangement of around the central atom. Okay, so there are two types: geometrical isomerism, which is cis trans isomerism. It occur due to different position around the central atom. It occur due to different position, I said. So position, underline position around the central atom. The ligand occupy position either adjacent to one another, एक side को ऐसे, or opposite to each other. Let's understand with the example. This is showing cis and trans. You can see one chromium is in center, 2 chlorine, 2 amine, 2 chlorine, 2 amine. But what is the difference? There is no number. This is not the difference in number. This is the difference in position. You see here, both the, let me take it, both the amine group or chlorine group are same side. Both the amine and chlorine group are same side. Okay, hope so you got this. And both the chlorine is same side. So you can see here, both the chlorine is also on same side. Whereas in this case, the chlorine is opposite. The chlorine is opposite to amine. Amine group is also oppositely arranged oppositely. So this type of arrangement is called geometrical isomerism. Okay, in which here you can say both amine is one side, mean adjacent to each other, that is called cis. Where both amine is opposite to each other, that is called trans. So mean when this type of cross type of arrangement is there, the trans. When there is a left and right type, that cis. Hope so you got. You can take some other example also. Optical isomerism, second type of isomerism of stereoisomerism, optical. Optic word you know very well. It is mirror. Or when you will see your hand in mirror, you can see, suppose this is my left hand thumb is toward north direction and this small finger is toward south direction. Okay, but if you will see this, now my right hand thumb is toward south direction and small finger is toward north direction, which is opposite to each other. Okay, that is called optical isomerism. So this is same here. Right side thumb is toward south, but left side thumb is toward north. So this you will see inside the mirror. That kind of isomerism is called optical isomerism. So it is optically active. It is occurring only in optically active substances. Okay, isomerism which rotate the plane of polarized light equally. जैसे क्या होता है, जब लाइट इस पर पड़ेगी, किसी स्ट्रक्चर पर लाइट पड़ेगी, तो लाइट की वजह से वो अपोजिट दिखता है, एंड बट इन अपोजिट डायरेक्शन. That is called optical active isomers. These are non-superimposable. Non-superimposable mean, what is the meaning of superimposable? It is like this. This is superimposable. क्यों? क्योंकि थंब के नीचे थंब दब गया है, फिंगर के नीचे फिंगर दब गया है, मिडिल फिंगर के मिडिल फिंगर, इंडेक्स फिंगर के नीचे इंडेक्स फिंगर और स्मॉल फिंगर के नीचे स्मॉल फिंगर. ओके, बट द superimposable, if we will cross like this, so it will not, see here, it will not hide each finger with the thumb के ऊपर small आ गई है और thumb के नीचे small आ गई है, तो it is not non-superimposable. That kind of structure is called non-superimposable. These optical isomerism also possess the property of chirality. Chirality is handedness, मतलब अपोजिट हैंड नजर आएंगे, ठीक है. Let's understand with the help of example. This is the example of optical isomerism. Same example I took chromium. Now here's trans NH3 NH3 Cl cis, sorry. Okay, when we will see inside the mirror the NH3 where this side NH3 is towards suppose left side, this side chlorine is toward right side. But when we will see inside the mirror, the amine will be toward right side and the chlorine will be toward left side. So this kind of image is called optical image. So this is giving us dextro and rotatory type also, sorry, dextro and levo type also. So dear students, this was all about isomerism. I will share one PDF related to notes of this isomerism also. So from there also you can note down the notes. But sometime question is coming by giving example. Suppose this example will given and they will ask you which type of isomerism is this. This is geometrical isomerism. Sometime question will come this type of example, which type of isomerism is this. Then you have to write solvated or hydrated isomerism. This is linkage isomerism. So this, for that purpose you should know the information about isomerism. So this is very simple topic and very easy topic. Hope so you got with the help of this video. So now till my next video, take care yourself and keep enjoying the digital classes, okay? But dear students, it is my again appeal, don't forget the systems. First thing, you have to watch the video through YouTube channel, you need to drop the comment. Second thing, you have to make your own video of 1 or 2 minutes and do share as a student reflection. Number 3, whenever test is there, suppose yesterday objective test was there, okay, although 20 student has given that objective test, but the moment after 10 minutes I called, I requested you to join me on live class, so only 11 students were there. Why? 9 student, first to 9 student, those who have given test, they have not joined me. Even it means that they had mobile, but they have not joined. So this is one thing. Second thing, where are those other students, other 10 students? Total strength is 29. If 20 student has given test, where are those 9 students? It means that you are not taking seriously. Now we are making the list of those students, those who are not cooperating. We will call them school every alternate day and we will teach them from school, okay? So be sure you have to be serious, you have to be study during this lockdown with the help of these digital classes. We don't have any other alternate. If you are facing any problem, you do share us with us, we will help you, okay? So be ready for tomorrow. Tomorrow we will going to start the valence bond theory, which is very important. Till then, thank you, have a nice day.